Okay, so let's look at some AS level maths differentiation and the power rule example. So remember from the introductory video what the power rule is. It says if we have, say, 2x to the 4, the power rule says we times the exponent by the front, giving us 8, and then we take 1 off the exponent, so 4 minus 1, and we get 3. Okay, so 2 times 4 is 8, and so the derivative of 2x to the 4 is 8x to the 3. So now let's look. So when we have a question, say we had a long question like this, which you're not going to get one this long, but we're going to differentiate each of these terms individually. So the first one is if we have a negative, that's fine. We just times the 2 by the negative 16. So 2 times minus 16 minus 32x, take 1 off the 2, and we get just x. If there's a fraction, same thing. 3 times a half is 3 over 2 x, and we take 3 minus 1, which would be 2, and so it's x squared. This next one here is the same as saying 3/4 x. So what I'm going to do is just say for that one, it's actually, we'll just write 3/4 x. Well, the derivative, when you have just an x with no exponent, in other words, the exponent's 1, the derivative is simply just the number in front of the x. Now this one, the square root of x, when you're using the power rule, you have to actually have a power. So what we have to remember is that the square root of x is just x to the half. Okay, so if you don't know that, it's very important to know that the square root of x is x to the half. Now, when we look at that as a power, a half times 1, because there's 1 in the front, is a half. And if we were to take a half minus 1, we would get minus a half. And so that would be the derivative. Now, they usually don't want you to have negative exponents. We're just going to leave that there, a negative exponent there for now, because we are not doing exponents in this section. So we will do that next time if you're not sure on exponents. The 3 to the root 3x to the 4, that is the same as saying. So let's just look at that. 3. Actually, I'm going to do this exponent because you're probably wondering what happens. So the x to the minus a half, remember that when you have a negative exponent, it can go to the bottom and become positive. So in other words, the x will go to the bottom and join the 2 and become x to the half, which could also be written as 1 over 2, and then x to the half we remember is root x. So this could also just be written as, when we simplified it more, root x. Okay, the 3x to the 4. Now what we do is we write that we can write as x to the 4 over 3. So in other words, whatever's inside the root goes to the top, whatever's outside goes to the bottom. Okay, so with this one here, inside was a 1. Outside, if it's a square root, that means there's a 2. So that's why we have inside was a 1 at the top, and outside it goes 2 here, which meant it was x to the half. So now that we've got this as x 4 to the 3, we can find the derivative. 4 over 3 times 1 is 4 over 3 x, and then when I take 1 away from 4 over 3, technically 1 is the same as 3 over 3. 4 over 3 minus 3 over 3 gives me 1/3. Okay, should know that from your fractions. So 4 over 3 x to the 3rd. Okay, now we're going to do pi to the x. Well, pi to the x can be confusing, but it shouldn't be. Pi is just a number. We know that that pi is an approximation of 3.14 dot, 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 dot. It's isn't it 128? Anyway, pi is just a number. And so we would just put in pi, because the derivative of anything next to the x, and if the x has no exponent, so if it's just by itself as an x, the derivative is just whatever sits in front of that x. So the derivative is just pi. Same with this. There's just an a sitting in front of this x, so it's just a. Yeah, this is the same as saying, now this one, 2 over x. Remember from our exponents that 2 over x, I can write, when this x goes to the top, it becomes minus. So remember from our exponents, when something jumps up and down, it changes sign. So this x technically goes to the top and becomes x to the minus 1. So what we're essentially doing is finding the derivative of 2x to the minus 1. Minus 1 times 2 is minus 2x. Minus 1 is minus 2. And so we're left with actually a negative here. So that wouldn't be a positive anymore. It would be negative 2x to the minus 2. Oh, right. But of course, we don't want negative exponents. So the x to the minus 2 becomes to the bottom. The x goes to the bottom and becomes positive 2. So it becomes negative 2 over, okay, let's just erase that. Make it neat. So it'll be negative 2 over x squared. And then, of course, pi doesn't have an x, so it goes away. So that's just 0, which we don't need to write. So that'll go away. And the 7 will go away because there's no x. Okay, so when you see pi, the derivative of pi is 0. Okay, so that's some more tricky examples. If you didn't, if I went too fast, you can obviously just watch the video. But again, you could even, some people, what they do is they turn the video down. They watch it at a slower rate. So that is another thing you can do if it didn't make sense. Okay, so those are some tricky examples that you might see in your exam.